Hi, good evening, everyone. Welcome back to PyData Pune event. Before moving to today's session, we would like to take this opportunity to talk about PyData and its mission. So, PyData is a non-profit educational initiative of NumFOCUS, which provides a platform to talk about things related to data. The aim of PyData is to promote things which are relevant to data, like science, data science, and data visualization, data management, and similar thing. So for tonight, we have a great talk for you, which is titled as "In Search of Best Practices for NLP Projects" by Ivan Bilan. Ivan is working as a lead data scientist at TrustU and manages data science and engineering team there. His academic background is diverse. Originally studied general linguistic and language teaching in his home country, Ukraine, then computational linguistic at LMU Munich in Germany, as well as technology management at CDTM Munich. He has been applying his technical and management skill on a diverse number of industrial NLP projects for a number of years now. His main topic of interest from NLP side of world is aspect-based analysis, aspect-based sentiment analysis of various type of users and product review in multilingual setting, as well as best practices for ETL and streaming ETL from the data engineering side. So without further ado, over to you, Ivan.
Thank you. Hi, everyone. Thank you for inviting me. Let me share the screen and the presentation so that we can start. All right. So I hope you can see the first slide. The title of the presentation is "In Search of Best Practices for NLP Projects." And this "in search of" prefix here is here for two reasons. First, it's the ultimate question whether NLP as a field is mature enough to actually be regarded as a separate field of machine learning or software engineering. And that we are going to explore in more detail today. And the second reason is, of course, I'm always in search of best practices, learning. So if you think something is missing here, please tell me. I'm going to add it. I'm always looking for more information on this topic. So I was already introduced. Just very quickly, I work right now as the lead data scientist at TrustU. We work with lots of reviews, hotel reviews, restaurant reviews. We analyze them. And the main focus on the NLP side is aspect-based sentiment analysis. And previously, I also worked as a data engineer and data scientist. That gives me a good perspective on different sides of sort of the field of data. Currently, I manage NLP and data science team and a separate data engineering team. And from the academic side, I've studied computational linguistics, general linguistics, as well as technology management. Right, so I am also the author and maintainer of the NLP Project. So this is a open source GitHub project. It's basically where I catalog all things I find related to NLP. A lot of the things I'm going to talk about in the presentation, you will also find there. Plus, I will also have separate slides with resources you can check later. All right, so let's start. First, let's try to sort of map out what are the steps that we take when we're building industry-grade NLP project. So first, we start with getting data. After that, building a baseline is very important to validate that your approach and the task can actually be solved. Then you build a prototype to validate it maybe with your clients. Then you spend most of the engineering time here where you build the NLP pipeline itself. Then you actually want to release it to your clients, collect more feedback either from your clients or just check by trying it out on your side, monitoring the data, the changes in data, changes in the NLP pipeline, and then basically you repeat this process over and over again because it is a cycle. You need to collect data again, redeploy your model, retrain it, and just work on it for quite a while. And so now we're going to look into each of these steps in more detail and try to see what kind of best practices are there. So we start with data. First, investing into data will bring you even more than investing into engineering time in your NLP pipelines. By different estimations from surveys I saw, if you, for example, spend 2 or 3 months just by improving your data, labeling it, you can potentially gain 5 to 10% in accuracy or precision. But if you spend the same time fine-tuning your NLP pipeline, you'll probably see a lot less gain. And so where do you actually start? Well, one way to get the data is to find it online. So there actually exist now lots and lots of data sets that we can use. And in recent years, especially I think this year, there's been a lot of interest from different companies in bringing all of those data sets together. Google released its dataset search, where you can search for data sets. There's lots and lots of compilations of data sets. There's a great open source project called Datasets from Hugging Face. All of these will give you very quick access to data sets. Since we are in the industry, it's always important to also check the license agreement of the dataset itself, because not all of them allow commercial use. And then if you can't find it, you can also generate some data. There are many ways of doing it. So first, you can annotate the data. And if you do so, you will face different challenges, right? The first question is, do you need to annotate the data in-house? Or do you want to hire someone or a freelancer to do that, or find a company that will do that for you? Well, there are pros and cons of each of those, right? If you annotate in-house, it really depends who you give the task to. If your NLP team or data science team is going to annotate the data, most probably there will be some bias involved, because they will be biased by how NLP models these days work. And so if you're doing it internally, it's better to ask a different either engineering team or some other team at your company to annotate data for you and write instructions for them. There are also now many companies that do data annotation. They are relatively cheap or expensive depending on what kind of quality you expect. Of course, there's the cheapest version with Amazon Turk, Mechanical Turk, which the quality there may be quite questionable, but there are better alternatives that are just a bit more expensive, but will actually provide you with better quality. There's Lionbridge, Appen, there are many other companies that can do that for you. Right, and if you can also get the data from by scraping it from different websites, or another alternative is to launch basically a prototype and collect that data through the usage from your clients. And no matter which way you go, there's also always an option to augment your data. So either generate synthetic data or basically multiply the data that you already have. And fortunately enough, this has been gaining more and more traction recently. There are now quite a few tools that will help you do that. There's NLP Aug, Send Augment, Wild NLP. All of these are open source projects that you can find on GitHub that will basically, you can take a sentence or a paragraph, and with these tools, you could rephrase it, rewrite it. There are many, many ways how you can basically multiply the data that you already have. And if you have more time on your hands, you could also invest in zero-shot or one-shot learning. These are quite more complicated approaches where you can teach your model to basically learn from very, very small number of examples. All right, so let's move on. So the next step is building a baseline. and a prototype. Well, before you actually start coding the whole pipeline, you want to actually make sure that basically your idea is solid. So you need to build a baseline first. And when you build a baseline, it will actually help you also uncover many aspects of your future work. So first, it will show you if the problem you're trying to solve is actually solvable with existing algorithms. So besides that, it will also help you set direction on what kind of approaches to choose. Maybe the problem you're trying to solve is actually not that hard, and you'll be able to solve it with a rule-based NLP system, or even XGBoost or some machine learning approach. And if not, then it will also set direction for you. Okay, you need to probably explore a more recent NLP approaches, I don't know, BERT and XLNet and things like that. And it will also force you to revisit your data. So when you're building the baseline, you will also see how well your data behaves. So you will see, is it correct? Is there any bias? Is the data imbalanced? And that will really help you basically to improve your existing data. And there's some quick wins that you can have. If you're building a baseline, you could use some existing AutoML tools like Tpot or AutoSKLearn. Just run it on your data, see what comes out. This usually output pretty decent results for a baseline. So after that, you want to build a prototype, some sort of low fidelity prototype, first of all, to validate that your project actually will be successful as an actual product you're going to sell. And you basically build a prototype, give it to a small subset of potential clients, or just do that inside your company and get as much feedback as you can. It will also help you shape how you're going to build your NLP pipeline. So maybe one of the requests from your potential clients will be that they need multilingual model, right? Maybe your prototype was only in English, but the overwhelming feedback is that you need other languages. So knowing that before you actually start building the pipeline will help you a lot. Right, and there are some tools that you can use to build quick prototypes. Streamlit has been very popular recently, allows you to quickly build some UI that you can show. You could also build something with Jupyter Notebooks. If you're using some sort of widgets, you can make it look nice enough to have a low fidelity prototype. Right, and when you're building the prototype, one more important thing is to also manage expectations here already. You don't really want to have a prototype that looks perfect, where precision is 100%, because then your potential clients will actually expect from the final product that it will be that perfect. So you need to already sort of manage expectations there, just give the results of your current model, maybe in your baseline with some errors, so that the clients already see, okay, there's room for improvement and it's not going to be perfect 100%. So that will, the sooner they understand that, the better, because let's face it, in the industry, you probably won't be able to build something that's 100% accurate all the time. Right, so after the prototype, you need to make some technical choices before starting with the NLP pipeline. And the first choice you're going to make is what kind of hardware and software you're going to use, right? So it really depends then on what you uncovered in your baseline and in building your prototype. Maybe the problem is actually solvable by training something simple that can run on CPUs. So you wouldn't need to invest in GPUs at all, but maybe it's the opposite, right? So you need to know that as soon as possible, so that you can then also, within your company, for example, request adequate budget to get some GPUs or even build your own machine and put it in the office, or buy something from the cloud. Or here you'll also ask yourselves the question, do you even want to start doing anything with GPUs, or is it possible to do it in a distributed way, for example, in Spark, where you would use Spark NLP? Maybe you already have sort of MapReduce cluster that you can use. So yeah, these are choices you should take sooner. And then also important to figure out what kind of software you're going to use, right? So are you going to use Python? Are you going to use Spark NLP? Are you going to use something else? Right, and adjacent to that, you also want to make choices on what kind of NLP framework you're going to use. There are right now, I think, more than 50 different NLP frameworks out there. So, and looking at recent surveys, I think the top 3 right now are Spacey, Spark NLP, and Alan NLP. And when choosing the frameworks, the main question for you is how well are they actually documented, right? You are in the industry, you'll end up having to re-engineer some parts of those frameworks probably. You'll be using them on a daily basis. So you want to choose something that has really nice, well-documented interface that you can use. And then it also depends on what kind of problem you're going to solve and how. So making those choices takes time, and you should do it before you start coding. And the last one, it comes as a best practice from software engineering. It's the idea that you should that your project should be modularized. So you should already think in what kind of components your whole project will have, right? Maybe you're going to have a separate pre-processing component that can be like a separate Python library, or the model training will be separate, evaluation will be separate. So thinking about that in advance will be very helpful. Right. Let's move on. There are also many different tools that you can invest in. From software engineering, of course, there's the typical continuous delivery and continuous testing tools like Jenkins, Concourse, and many others that will really help you making sure that what you're building is well tested and monitored. Then, especially if you're working with data, I mean, in NLP, you are working with data. So a good investment is data versioning, right? You'll probably change your data a lot. You're going to collect a lot new data. So you want to look into tools that will allow you to track that data as well. There's a great open source project called Data Version Control, DVC, that you can use for that. There are also some paid services like Pachyderm, Monte Carlo, Weights and Biases. These also have very great tooling for data versioning. And you also want to already start thinking about interpretability, right? You want to know actually what's going on in your NLP model that you're training. Unfortunately, there's not that much tooling for that. Only this year we saw LIT, which is a tool for language interpretability from Google that just came out recently. It works pretty well, depending on what kind of models you use. There's also Interpret Text, which is as well open source. So trying to think already about that will be very helpful. There are also some general machine learning tools like Interpret, Lime, Shep. These are not always applicable to NLP, but depending on the problem, they can still be useful. And then you want to also invest into more rigorous testing, right? We already saw there are CI/CD tools that will help you with that, but that's more from the software engineering side. And you usually in software engineering, you write unit tests, integration tests, things like that. But in NLP, we actually have different kind of tests as well, right? We want to also evaluate and verify the output of our model. And since recently, there has been this new sort of paradigm in language testing called behavioral testing. Basically, the idea is that we want to somehow test how will the model react to a change in text? And recently, there's actually been quite a few new tools that help you do that. There's an amazing tool called Checklist, which is open source as well. There's Text Attack, and there's the general data testing framework, Great Expectations, that you can use. And the idea here is that you write tests in a way that you sort of give a sentence to your model and you have an expected output, and then you apply different transformations on that text. A good example is something I've heard from the industry is there was a sentiment analysis model. Basically, the sentence was, I like USA, and the sentiment analysis model always said it's a positive sentence, right? But when you apply this kind of behavioral testing tools and you change USA to a different country, sometimes it actually, the same model, even though it says I like and the country name, outputs negative input, negative sentiment, basically. Why is that actually happening? It's because many pre-trained models that we're using are inherently biased. They have been trained on lots and lots of data scraped from the internet. And so there's a lot of bias in them that can influence the output if you change some inconspicuous thing. So these tools will actually help you catch these issues much earlier before you basically go to production. And yeah, and another example, you could also prepare yourself for some adversarial attacks, right? So adversarial attacks are not so common yet in NLP. It's probably a term you mostly heard in computer vision. But a good example is, let's imagine you have a toxic comment classifier, right? And someone has figured out that if they exchange one specific token to something else, your classifier will not mark that comment as toxic at all. And so they will be able to post toxic comments online. And so you want to prevent that. You want to have a robust testing framework that will catch these things before someone actually tries to do that on production. And of course, you also want to invest in responsible ML, responsible NLP. Here, there aren't that many tools available. So first thing you want to look into is, of course, privacy. So GDPR is a thing every company needs to be GDPR compliant. So you'll actually be doing a lot of data anonymization in NLP. There aren't, unfortunately, tools, or at least I don't know of any. So if you know of any automated data anonymization tools, tell me. There are some approaches how to do that. There's a nice blog about Flare, how you do that in the Flare framework, but that's about it. You also want to make sure that your model is not biased, right? So you want to invest a bit into ethics and bias. Unfortunately, there's also not that many tools. There's a good resource called Ethical Institute. It's a website, actually. If you type it into your browser, it will take you to this Ethical Institute that has lots of white papers and ideas on how to actually make ML more ethical. And you also want to make sure that your results are reproducible. For that, there are actually some tools. Again, you can do that in DVC, in ML Flow, and weights and biases, where it will help you track the models that you output, track the states, how you train them, and make them more reproducible. All right. And then you go to building the NLP pipeline, right? So there you start with data processing, right? There's basic data cleanup that we usually do, like cleaning up null values, adding missing data, or imputing missing data. This is some NLP-specific data processing, basic things like post tagging, sentence splitting, spell correction, stemming, many things out there. And then the next step is feature and task engineering. So especially if you're doing ML or rule-based approaches, you'll be doing a lot of feature engineering still. But if you're more using like recent transformer models, what you're probably going to be more engaged with is in task engineering. For example, if you want to use T5, a transformer model, T5 was actually written for question answering first and foremost. But what you can do is re-engineer your own task and basically turn it into a QA task, where, let's say, a sentiment analysis task, you could pose a question that is the sentence itself, and then expect from T5 to return a span that has a sentiment. So this is something you're going to engage in more. Then, of course, model engineering. Here, most of the time, it's similar to ML. There are, however, some best practices that are specific to NLP. Things like word dropout. You can drop out random tokens from sentences and replace them with like unknown token. That will help keep your model more robust and unbiased. There's also these like learning rate warm-ups that have been introduced mainly by transformer models, but in general, it's very typical things you do in ML as well. And then evaluation, of course. You want to choose the perfect metric that fits your task. So whether it's accuracy, precision recall, blue or rouge or some other metric, it most of the time depends on the problem you're trying to solve. Right, and it's a cycle. You evaluate, you push it somewhere, try it out, and then maybe you need to change your pre-processing, change your features, do more model engineering. So yeah, that more or less never ends either. And so after that, you actually want to also build NLP models that fit on production, right? So you can start with choosing some existing optimized models, right? You can select Distilbird, Mobilebird, Minibird. These have been introduced very recently. They are also mostly open source. You can find them in Hugging Face framework, and also from the companies that have came up with them. There was a nice presentation in this meetup before going in more detail on this, so do check it out. It was very insightful. And you can also, from your side, invest more engineering time into model compression. There are different techniques out there that allow you to do that. Pruning, quantization, knowledge distillation, and many others. They do, however, require quite a lot of skill in these approaches, and also a lot of time investment. So it really depends whether you have the budget to do that or not. And I'm going to share a few resources on this that you can check out later. Right, so we could talk about NLP pipelines more and more, but when you're building NLP pipeline, a great start is this great book that came out recently called Practical Natural Language Processing. It's great. It walks you through almost all the steps you need when engineering them. And there was a really great workshop recently at EM NLP called High Performance Natural Processing that goes deeper into this idea of how can you make your models faster, how can you make training faster and inference faster. So I'm going to share the link later to the recording. It's really great. Right, so when you have an NLP model, the next step is to deploy it. Right? You want to bring it to your clients. So where do you start? I mean, first of all, you need to have the right skill set in your team. There's this really interesting idea that you should leave probably the deployment of models to data engineers or ML engineers. So data scientists are usually very good at machine learning, good at advanced analytics, statistics, but data engineers mostly know how distributed systems work, how cloud approaches work, and they are more fit to do that. Of course, it doesn't matter data scientists can't do that. In many data scientists I saw are more or less unicorns that can do both, which is great, but it's not so easy to find them on the market. So you're better investing in data engineer or an machine learning engineer, which is sort of a new kind of title in data science world. Machine learning engineers are actually there for this specific purpose, to take the NLP or ML model that has been built by your data science team and put it on production in a way that it's well scaled, that it works for everyone and delivered for everyone. Right, so investing in the right skill set is great. And the next thing is there are also some best practices that I've seen that we can borrow from ML ops and data ops. There's this idea of data mesh, which for NLP I think applies very, very well. The idea is that you store your NLP data outside of the central database where everything else is stored in your company, mainly because this data will be changed a lot, right? NLP data changes a lot. You probably want to, you'll collect a lot of more data, you'll change it up, you'll have different columns and things like that. So it's better to completely separate it from the regular data that's used in your company. And that's the idea of data mesh that comes in here. And then you also want to do proper model packaging and serving, and that if you have data engineers or infrastructure engineers or machine learning engineers, they will know how to do it properly. But there are some things to consider. First is a good setup for model governance. And model governance, or also called model registry, or there are some other names for this, is the idea that you actually keep track of all models that you train, you store them somewhere, and you can exchange them in case the new one is somehow biased or doesn't work. And so you track that, and you are also able to monitor how your model behaves. And there are some approaches from MLOps for deploying the models that we can use here. There's one interesting idea of blue-green deployments, where you have two models, so the older one and the new one, and you deploy both of them at the same time. You use the latest one, and there are tools that, if you detect that something is wrong with the new one, will let you quickly switch to the old one. And that's the idea of blue-green deployments. I'm going to share some resources on this that explain this in more detail. And there's also this other idea from, I think, DataOps called canary deployments. The idea here is that you deploy your model only to a small subset of your clients on production first, right? So you test your model there, like on a small subset, and the rest of the clients are still using the old model. And if something goes wrong, your product or your output will only break for a small subset of clients. So you're not actually bringing the whole production down. And again, I'm going to share some resources for this as well. Right, and you also want to invest in model scaling. Really depends how to do that. You can keep the models somewhere in the cloud, on S3 or on Azure. And then you can also, it's always a question, how are you going to deliver your model to the clients? Is it going to be API-based? Is it going to be batch-based? Do you want to put it on Kubernetes or some other platform? And it really depends on your use case, of course, and it really depends on the skill sets that you have in your team. But there are many, many options how to do that properly. Right, so after that, when you deploy to your clients, a great way to gather feedback is to have some sort of a feedback loop in your product itself, right? Your clients will usually react much faster to wrong data than you do. And so if you have some way in your UI that they can report those issues, it will be very helpful for you, because you can collect all of that data. You can analyze it. You can even have some metrics based on that to also evaluate how good your model is based on the number of errors that your users report. And in the end, all of these reports could end up in your training data as well. But here, you should really think about having a human-in-the-loop check somewhere in between. You don't want to feedback everything that your clients report directly to your model, because, first of all, they may not be always correct, and sometimes they can also have malicious intent. As a good example from a few years ago, if you remember, there was this chatbot called Tay from Microsoft, which was basically a Twitter-based chatbot. And it had this idea of continuous retraining inside it. So basically, when people wrote to the chatbot, it used that data to retrain itself and learn from that. And of course, I think you've all heard what happened to Tay. It was shut down after just one day being online, because people started writing some really nasty comments, and then it learned from them, basically. And it turned into a very uncontrollable, raging teenager on the internet or something like that. And so Microsoft had to pull the plug, and that's mainly because there was no human-in-the-loop check. Right, and so after that, you also want to track how your data and how your model behaves, right? So there's this idea of data observability, which I think is also a relatively new paradigm in data science and data ops. It's the idea that you want to continuously track how your data is changing, how well is your model performing. So you want to track data drift, you want to track model accuracy drift. You can also track user behavior, how are users interacting with the NLP product that you have. There are also some tools for that. And since we are all working with natural language and the data that comes from there is very unpredictable, and it also changes quite a lot. The trends in language change. The most recent example is, of course, COVID-19, right? It has completely changed how we write the topics we write about on Twitter or online. New terms that pre-COVID-19 NLP models haven't even heard about before. So you need to somehow adapt to that. Unfortunately, there aren't that many tools that help you track those trends. I'm going to share a resource on this later. There's a really great talk by David Dodson from Quartz News. He shows a really nice sort of trend graph of different topics that they track from different news sources. I'm going to share the link later. It's really insightful. And how do you do this? With some tooling. I mean, you have the typical software engineering tools you can use: ElkStack, Sentry, New Relic. These can be used to report issues with your models, or not necessarily track data drift or model accuracy drift. But there are some specific data and ML tools that you can use. For example, Monte Carlo it's a paid tool, but it has a lot of functionality built into it related to tracking how your data changes, how your model changes over time. Also, Pachyderm, MLflow, they all have some sort of features that you can use in order to do that. Right, and after you do all of that, it's a cycle. You get more data, you have to retrain, evaluate again, deploy, monitor, and go over and over it until you reach some sort of nirvana in terms of NLP models, which probably will never come, right? Because you'll need to add new features, the expectations from your clients will change. So this is a cycle that takes a very long time. Compared to regular software engineering, it's very different, right? When you're building an app or a website, you push it online, it's there. You do need to add new features, you do need to fix bugs, but you usually don't go and re-engineer the whole thing, which is something that happens a lot in NLP and ML, where you have to often rewrite your pipeline to adopt it, basically. Right, so that's more or less it. Thank you for your attention. So I put the slides online. You can find them on the link on the left. I also post a lot about NLP. So if you're interested in that, follow me on LinkedIn or GitHub. Yeah, and thank you. I'm open for questions now. I also have a few slides with different resources, things I talked about. You will also find that in the link that I shared here. Thank you.
Thank you, Ivan. We have a question from Rushi. Any suggestions for feature selection method for traditional NLP machine learning models?
Sure, great question. Feature selection for traditional NLP models. Usually, from what I see, a lot of those features are based on the regular things like part of speech tagging, dependency parse tags, named entity recognition, and things like that. So you can build quite a lot of features based on that. The ones that I saw working really well are dependency parse features, but it also depends on your problem. And in terms of tooling for that, I don't think there is like one tool that will automatically extract features for you, but I think the open source community is working towards that, and I hope to see something coming out soon. Right, and maybe related to this, there's this other idea in ML overall called feature store. And this idea is that if you have multiple models, you want to actually save the features you extract and somehow have them as separate components that you can reuse for different models. There are some tools for that, but I think they're still in its prime. So you can do that, I think, in Amazon SageMaker. There are also a few other tools that allow for that. But overall, I think there's still a lot of work to be done there.
Okay, and here I have my next question. So this is a comment by Sean. He says, thank you, Ivan, for this great session. As a statistics undergraduate looking to specialize in NLP, what would you recommend is a good place to start?
Yeah, that's a very good question. I think that a good place is always to start with some smaller projects. So you could find some NLP tasks on Kaggle. You could do, there are also a lot of NLP courses from really good universities online that you can check out. So there's I think there's an NLP course from Stanford that's fully available online on YouTube. It's really good. It has like it goes from basic topics up to the more advanced ones. And I think it's lots and lots of sessions, hour-long sessions that really go into that topic. There are also not that many books, I think, that you can follow, but mostly online resources, mostly on YouTube. There's quite a lot of content that you can find.
Okay, and there's one question that I have. If you can talk a bit more about ethics in AI and machine learning.
Sorry, so could you repeat the question? AI and machine learning for what?
Yeah, if you can talk a bit more about ethics in AI
ethics.
and machine learning.
Yeah, that's a good question. So when it comes to NLP, I would say as I've said already, if you're using these pre-trained models like BERT, Electra, and things like that, they have a lot of inherent bias in them, right? They have been trained on lots and lots of data online. Another example is GPT, right? GPT-3 and GPT-2. It's basically trained on posts from Reddit, I think. So there's lots and lots of stuff there that comes from the internet, and we have to be very careful with using them in production, right? We need to make sure that these things do not lead to some bias towards some ethnicity or any other form of bias. So we need to spend more time in testing our models, making sure that they are not biased, basically. So that's one thing. And as I've said, unfortunately there aren't that many tools out there, right? So I know there's a lot of interest. I've seen in recent conferences people are thinking more and more about ethics in AI overall as well, but I think we still have a long way to go, right? The most important thing, if you're in the industry working on NLP or building ML models, just make sure that you put off some engineering time to actually test those things, right? You don't want to end up with some complaints from your clients. You can actually catch those things before you go to production if you invest adequate time into that.
Okay, I have another question from Sabrina. Do you have any recommendations in how convincing traditional software engineers that are skeptical in investing in data, but rather tend to focus more on engineering?
Yeah, that's a very good question. I think I see that quite a lot. It's actually not an easy task, right? If you want someone to invest in data, probably the best thing is to spend some time yourself and build some low fidelity prototype that will actually prove that using some data science approach to solving a problem will be effective, right? It's often not enough to just tell them, hey, I'm sure this will help. I'm sure this will be better. It's always better to spend some time to build a quick prototype, to build something that kind of works, and then show it to them. So that's one way to go. Another topic related to this is, of course, the thing I see in the industry right now. I think the industry is still not very much ready to embrace these new deep learning approaches. There's still a lot of misunderstanding about why we need GPUs and why can't we just use the regular CPUs that software engineers are using. There's still a long way to go there, I think. And yeah, we're all in it. Let's try to improve it somehow. Let's try to, do some AI evangelism to prove that data is actually the answer most of the time, and we should invest into it more and more. But yeah, it's a tough problem to solve.
Okay. I do not have any more questions. So can we wrap it up?
Yeah, sure. Thank you again for inviting me. I hope it was insightful to the audience, and yeah, hope to come back to the meetup at one point again.
Yeah, sure. So thank you, Ivan. We are very grateful to you for sharing your time with us. We had really great questions and answer coming. Thanks a lot, everyone. This talk shall remain on YouTube. Thank you once again, and hopefully we'll connect soon. Thank you.
Thank you. Then bye. See you.